Okay guys, last example for this section. I've tried to really load you up with examples so that you have lots and lots that you can go back and look at, but this one is just a little bit different. I'm not going to walk all the way through the integration by parts on these. I just want you ideally to pause and look at these on your own ahead of time and try and decide, would I use substitution or parts, and which would I use first, and do I have to use both? So just decide, do I use one, do I use the other as my first step? After that, am I good, or do I have to use another trick? Okay, so looking at the first one, here's the deal. All of these are products. As you look down, every single one is a product. So, oop, I lied to you. D is not a product. Okay, so let's look at that. Lots of products here. The trouble with products is they could be something that's part of a product rule, but they could also be something that's part of a chain rule. So what you're really looking for here is a couple of things. Am I just multiplying two basic functions, no composition at all? If yes, that's probably not going to be a substitution. That's probably going to be a product rule. If there is composition, does substituting out an inner function eliminate all the extra variable stuff floating around or not? So I think those are my two big questions. See if I can think of others as I go. So here I have an x squared, that's a basic function, but sine x cubed, not so basic. That's definitely a composition. So the next question I would ask myself is, if I try to substitute out the x cubed, is that going to work nicely with factor number 1 sitting over here? And the answer is yes. The derivative of x cubed is 3x squared, so it should actually wipe out both, which is fantastic. So I would say that w equals x cubed is a really nice first step. We're going to get dw dx is equal to 3x squared, and then we can move the dx up. And then we can divide by the 3 since I don't see it floating around. So I'm going to say that the sine x cubed becomes a sine w, if I can remember my variable. The x squared dx becomes a dw over 3. So I'm just going to go ahead and move that 1/3 out in front. And then that's a basic function. I should just be able to go from there and not get into too much trouble. Okay, let's look at the next one. The next one is similar. I still have a sine x cubed, so I still have a composition, but this one looks a little less promising on the fact that if I choose w equals x cubed and get dw over 3 equals x squared dx, it doesn't get rid of all those x's out in front. But if you mentally split this up and say, okay, I have my sine of x cubed, I have 5 x's sitting out in front. I'm going to move 2 of them back with my x squared so that this can be replaced by 1/3 dw over 3. I know that the w can replace the x cubed, and then if I look, I have an x cubed out in front, so it can actually replace that as well, which turns this into a w sine w dw over 3, and I'm going to move that 1/3 out in front. This is not a basic function, but this is way less messy than what I started with, and this is a fairly basic integration by parts. So now I would say algebraic trumps trig or exponential. So let's let u be w and dv be sine w dw, which means v, derivative of cosine, is minus sine. Okay, so that should turn it into something nice. You'll have your u times v, but the integral will only have a negative cosine w dw, so that will be really easy to integrate. So the first one, straight up substitution. The second one, substitution to make it a little nicer, followed by parts. Okay, the third one, again, I do see composition. I would point out that you can use log rules. A lot of people just totally space, but one of our log rules says we can move the 2 down in front, and then we could just go for by parts, and it wouldn't be too bad. We can also, if we don't spot that, say, well, if I try and pull that inner function out, it's actually going to be fairly nice because I have an x sitting out in front that I can use to switch to dw's. So that would turn it into hold on, let me look at what it would turn it into. So x dx becomes dw over 2, so there's going to be a 1/2 and a dw. X squared is replaced by w, so it's the natural log w dw. Okay, so this is fine, but we're not really any better off than if we used a log property. I think that's totally a wash in this case, because either way we actually have to use integration by parts. The natural log of w is not the derivative of a basic function, so our next step here would be to say it's easy to take the derivative of natural log w, but it is not easy to take the antiderivative. So even at the risk of introducing an extra variable, this is still a good choice because, again, you'll get your u times v, w natural log w, but the thing you're integrating will be the integral of v du, and v times du just leaves us with a dw. Very easy to integrate. So if you use log properties, you're still going to do an integration by parts, so either way is completely fine. And if you want to use these for practice and go a little further than I did, remember, you can just truck over to wolframalpha.com and you can just type these in. Just type in integrate x, and then if you do the little shift 8 to get the little star, and then I think you can just type in ln x, if not log x. It'll give you some tips if you type in something and it doesn't think it knows. Or you can Google how to type things in. It's pretty user-friendly, I think. Okay, sine x to the 4th. Looks kind of terrible. U substitute isn't really going to get rid of anything. I'm tempted to try out by parts. So it doesn't actually immediately jump out at me either. And this is what I'm saying. It's not supposed to always be obvious. So just try things. If I'm going to try it by parts, I definitely don't want sine x to the 4th to be my dv, because that is very hard to find the antiderivative of. If I knew its antiderivative, I would know the answer and I wouldn't do by parts. Okay, so if I do this, derivative of sine, so I'm going to get cosine of x to the 4th, and then I'm going to multiply by a 4x cubed dx. Okay, let me check out what happens. So I get x sine x to the 4th minus the integral of, I'm going to move the 4 out in front, x to the 4 cosine x to the 4 dx. Well, that's not particularly nice, but it might be doable. Let me think about this. So now, if we try and substitute, I might have given us a terrible one, and I might have done it on purpose and just forgotten that that was my plan. Let me just think what happens if we do w equals x to the 4th before I try any further with this horrible mess I just made. I'm not loving the look of x to the 4th cosine x to the 4th. If it was x cubed cosine x to the 4th, I'd be kind of excited because that would work nicely on a substitution, but that looks terrible. I hate it right now. Okay, so dw is 4x cubed dx, and we can divide out that 4. Okay, so in fact what we really have to do is divide out both of them because we don't have an x cubed anywhere that we can snag. I should have done this in a different color. Okay, pretend this is blue. Doing the blue thing, we'll switch it to a sine w, but then we're going to have a 1 over 4x cubed dw. And I don't love that, but I could say that the 4th root of w is equal to x, which means up here, I'm going to move the 1/4 out in front, I would have 1 over, or we could even say it, let's say it this way, w to the 1/4. I think I like that better. And then if we plug that in and we cube it, we're going to have w to the 3/4 sine w dw. I think I made up a terrible one, which is either because I wasn't paying attention and I thought it was a good one, or maybe it was to point out that sometimes problems just suck. I don't remember, but I'm going to say this one is terrible. Both of these seem like they're getting completely stuck. I feel like I'm stuck here because I could try integration by parts, but neither of those is ever going to disappear. And unfortunately, taking either derivatives or antiderivatives of w to the negative 3/4 is never going to get you back to w to the negative 3/4. So I don't think our do by parts a couple times and see if you can solve trick will work at all. Down here, I feel stuck because if I try and sub out that x to the 4th, it's not going to quite cancel out the 4 out in front. It can cancel out 3 of them, but not all of them. So I think I'm going to get stuck with those powers again. Let me just think if I did another by parts on that. I think it's just going to keep giving me that mess. So it's possible that if you keep going on that one, you'll get something beautiful, and I've just forgotten. But right now it is looking like a lost cause. So for the sake of you not having to watch me go round and round with it, I'm going to say we called it quits. Okay, so not to be confused with x cubed sine x to the 4th. This one works beautifully. Now we can go back to just substituting out 4x cubed dx, which means we're going to end up with the x cubed dx being replaced by a 1/4 dw, and then the sine of x to the 4th becoming a sine of w, and that one is fantastically easy to complete. So I think maybe I was making the point that sometimes they're really bad, but as soon as you throw in some extra x's to play with, they can get better. F is another one where substitution won't immediately turn it into a basic function, but it does greatly improve the situation, because if we look at this and we say, okay, well, let's separate out 3 of those x's in the front, and we can use the exact same substitution from above, and that will turn it into this x cubed dx becomes a dw over 4, so there's our 1/4, and this is our dw. And then the x to the 4th out in front doesn't go away, but it is our w. So now we have a w sine w dw, which you can do, I think that one was up here, right? You can do with, yeah, right here, with a by parts. So combinations of substitution and parts absolutely happen and can be helpful. Thanks for watching.